We want to look at a few more examples of factoring a trinomial. In part B, we want to, again, identify two values, a and b. In this case, we need the product of those two values to equal -72, the value of that constant at the end of the expression. And we need a plus b to equal -1, which is the coefficient for that x term. Again, this generally comes down to some trial and error, but in this case what we would want is our value for a to be 8 and our value for b to be -9, because those two numbers would multiply together to give us -72 and add together to give us -1. Meaning we can factor this trinomial as x plus 8 times x minus 9. And again, we could multiply that expression back out and verify that we get back to the original problem we started with, the original expression that we started with. In part C, we need our values a and b to multiply together to give us -70. And we need our values a and b to add together to give us -3. In this case, the two values that would work would be -10 and 7. I figured these out ahead of time, so I'm coming up with these answers, but there's no real magic to it. It's literally just trying to find some different values that multiply together to -70, and then check to see if they also add together to give you -3. If not, then you need a different pair. But once we do find those values, we know that we can rewrite this as x minus 10 times x plus 7. For part D, we need our values a and b to multiply together to be -14. And we need our values a and b to add together to give us -5. In this case, the pair that would work would be a equals -7 and b equals 2. So we can write this factored expression as x minus 7 times x plus 2. And then again, on quizzes, especially on tests, it's a really great idea to take that step of multiplying your result out to verify that you get back to that starting expression. It won't fix your answer if it's wrong, but it will let you know if you made a mistake and you need to go back and try a different pair of values.